Okay. So when we're using the law of sines and cosines, we've got two different options here depending on the information that you're given. The law of sines just looks like a bunch of proportions and it's pretty basic to use. So if I have two sides, or sorry, two angles and a side, I can find another side, right? And even if I have these two angles, but I needed this one, if you have two angles, you can always find the third. So two angles and a side, that means I could have angle, side, angle, or angle, angle, side. Either one of those situations would get me the information. Either I'd already have the information I need for law of sines, or I could get there, right? And then what's the other one that we use for law of sines, where we have to go check things? The ambiguous case. Okay, if I have two sides, can I find two sides and an angle, can I find another angle? Yes, but that's when I have the two sides and the non-included angle, right? That's the ambiguous case where we have to go and find both options and then check a bunch of things, right? So law of cosines, that is, you have an angle that's related to the side across from it. And so you have to have one to find the other. And that means I've got to have two angles, and two sides and one angle to find this side possibly. So like these two sides and this angle could help me find this one. So that would be two sides and the included angle. That would be a side angle side situation. Or I could have all three sides and find the angles that I need. Okay, so those are your 5 different ways to decide what you want to use. But honestly, if you are not sure which one to use, if you try one of them and you get stuck and you can't substitute stuff in, it was probably the other one. I mean, you can always, sometimes when you hit the roadblock, that's how you figure out that you're doing it wrong. So we are going to jump to example 2. And so we have this, we need to solve it. And one of the differences between this and what we did the other day with these is the other day we just found a side, or we just found an angle. Here we're solving the triangles, which means we have to find everything we don't know right now. I can't start by finding another angle right now, so I'm going to have to start by finding this side. And so right now I have two sides in the included angle. So this is a side angle side situation, which means would I use the law of sines or cosines? Cosines, okay? So the law of cosines, so this is going to be, I'll call that x. So that's the side I'm looking for, goes on the outside. X squared equals the two sides you have squared and added together. And then you can type all that in. You can either do it all in one step by putting everything on the right underneath the square root sign, or just typing in everything on the right and then taking the square root of that number. I guess I set my paper down over here. Okay. So what did we get for the length of PQ? 31.987 kilometers. Good. Now we want to store that because we're going to need to use that to find our angles. So with that full long number in your calculator, store it somewhere. I called it X, you could store it in X. Okay, and that's what I would do because I have that there, and that's where I would have stored it. Is everybody okay on how to store things? Yes? So you're going to do second to recall because that's your store button, and then you just hit whatever letter you want it to store in. X, whatever. Or I'm sorry, shift, not second. Pick a letter. Or X and Y, yeah. Okay, so now that I have that, I need to find an angle, right? And I have to find P and I have to find Q. Angle P comes first, so we can find that one. Can I use the law of cosines to find angle P? Yes. Can I also use the law of sines? Would you say the law of sines is a little bit easier? I mean, it's a matter of opinion, but that one's just a little bit more basic to do. So I have the information where I can use the law of sines. So it's okay once you find that to switch to the law of sines. So we're going to say the sine of angle P over 28 is equal to the sine of 87 over x. And I can put x there because that's where I stored it in my calculator. So everything I've written down makes sense. This is x, which is what I've already found. So it's not like I'm making anything up. Then it's just a matter of cross multiplying. 28 times the sine of 87, and then I divide by x, and you literally divide by x in your calculator. When you do that, you get a decimal, which may not make a whole lot of sense. Is that your answer? No. What you get when you cross multiply and divide by x is the sine of p. You don't want the sine of p, you want angle p, so what do you have to do? Sine inverse. So you take the sine inverse. Found it. And you should get 60.945 degrees, right? Okay, so now I need to find angle Q. I could use the law of sines to find angle Q, but do I need to? No. I can take what's looking at me in the calculator, I can add 87 to it, and then I can do 180 minus that answer, and it keeps everything stored in there for me without me having to store anything. And you should get 32.055 degrees. Everybody okay with that? Do what again? Yes, you have this answer looking at you in the calculator. Okay, so I added to 87 and subtract that from 180. Okay. And that's all the work I have shown, and that's plenty. That's all I have to have. And then the calculator does the rest for you. Okay. Any questions at this point? You just got to make the right decision on which one to use. All right. Any questions? All right. Let's flip over on the back. Let's look at example 4. So I've got to draw this picture. So here's my triangle. W, X, and Y. WX is 9. XY is 15. Angle W is 31. And I have to find all of the pieces. So what do I have to start with here? Law of sines or law of cosines? If I'm going to start with the law of cosines, the angle and the side that are across from each other, I have to be looking for one of those. And I'm not, right? And so I would have to find what? I would have to use what? Law of sines, because law of sines is going to let me use this angle and this side, and then this side, and I can find this angle right here, right? Because this is the side-side angle situation, which is the ambiguous case, which means that I'm going to have to check myself once I find it. So I'm going to have the sine of 31 over 15, and that's going to equal the sine of y over 9. So I cross multiply 9 times the sine of 31, right? Divide by 15. You should get a weird decimal again. That is not your answer. That's the sine of y. So then what do? Sine inverse. So then you get the measure of angle y equals 18.000 degrees. Now, because I'm going to have to find the rest of this stuff, you want to store that. Since this was angle y, storing it in y makes sense. Okay, that's where I would suggest that you store it, but you can store it anywhere you want as long as you remember where you put it. But this is the ambiguous case, so I can't just say, hey, this is the measure of angle y. I have two options for that angle, right? How do I find my other option for angle y? Good. I take 180 and I subtract that angle right there. So you can do 180 minus y because you just stored that. And your other option then is 162 18.000 degrees. So they may not all work, or they might not both work. Maybe neither one of them work, right? How do I decide that? I have to add it to this 31. So 18 plus 31 is less than 180. That's all I care about. 18 works. 162 plus 31, that's more than 180. So this one doesn't work. So thankfully, I only have one angle that, or one number that could be angle y. So it's 18.000 degrees. So now that I have that, and I have stored that in there as y, I can just use the y that's in my calculator now. And then, yes, I can add that to 31 and subtract that from 180 to find x. When you do that, what do you get for x? Yeah, so it's 131.000. And then you want to store that in x. That way you can use x and y when you're actually doing what you need to do. So now I need to find wy. Well, wy is across from x. So I can say that the sine of x, which I have stored in my calculator, over the length of wy is equal to the sine of 31 over 15. And then that's just cross multiplying and dividing there. Okay, what do we get for wy? .980. Good. And that would be meters. I'm sorry, what? You could have done cosine if you wanted to. It would be yuckier, but yeah, this is fine. You'll get the same answer. As long as you have the information you need, you'll get the same answer. Doesn't matter. Not if you just hit cosine here. That's not what you're asking, right? Okay. All right. Any other questions? All right, good deal. So let's look at drawing these, because this is where that, the drawing the pictures and the whole bearing thing comes into play. It says Cincinnati, Ohio is 540 miles due east of Kansas City. All right, so east is this way. So here's Kansas City. Cincinnati, Ohio is 540 miles due east. And this is Cincinnati. Okay. So then it talks about the bearing from Kansas City to Nashville. All right, so to get the bearing, I'm starting at Kansas City. So here's my north, south, east, west, right? So the bearing from Kansas City to Nashville is south 64 degrees east. So I'm going to go south and swing 64 degrees east. So it'll be like right here. And this right here is 64 degrees. Okay, does that make sense to you? Here's where I think that people were unsure of what to do. Is that, when you draw your x and y axis, your x and y axis is there. And the origin is where it is. And you can put points in their place, but you don't get to just like move the axes around. But we can decide north, south, east, and west from wherever we're standing. So each one of us has a place that's directly north and directly east and directly west of wherever we are right this second. So even though I have this and I drew this little x and y looking thing here, I can do the same thing from here. North, south, east, west from Cincinnati, right? And so from Cincinnati, here's my little compass-like thing. I'm going to go south 29 degrees west. It's going to swing out here, and this is 29 degrees right here. And that's 64, and that's Nashville. Does that make sense? And I think that's where people had issues with that first word problem, because you didn't realize you could redraw that, because I didn't say that, and it's confusing if you've never done it before. I didn't really think about that. Okay, so now that we have that, it says in A, we're going to find the distance from Kansas City to Nashville. So we're going to find this. I'll call this x. So right now, I have that this is 540, this is x that I'm looking for. I don't have any angles in my triangle, but can I figure out what some of the angles in my triangle are? Yes, because since this was due east, this is a right angle, right? So if this is 64, can I figure out this angle? Yes, this is going to be 26. And since this, again, was due east, that's a right angle, so 90 minus 29 is 61. So I have angle side angle, which means it's going to be the law of sines, but in order for me to actually use that, because I can use the 61 in the x, but I got to use this 540, I don't have this angle here. Can I find that? Yes, I can add these two together and subtract from 180, right? And what do you get? 87 degrees. 93. Right? So now I can find x, which is the distance from Kansas City to Nashville, because I can use the 93 and the 540. So the sine of 93 over 540 is equal to the sine of 61 over x. So then when I cross multiply, do my thing, and then I can say Kansas City is blank miles from Nashville. Do you have something? You never do. Tell me what you got. I don't care. So what if she was wrong? Then it's okay, as long as you're not the only one. Okay, got it. It's 472 point, I didn't leave myself enough room, 943 miles. You need to have more confidence, dude. 472.943 miles from Nashville. Everybody okay with that? All right. So then B says, find the distance from Cincinnati to Nashville. So I want this. We'll call this Y. So really, it's just the same thing. We're just using 26 and Y now. So I can say the sine of 26 over Y. And then I would use the same pieces that I had from the beginning there. The sine of 93 over 540. So I can say Cincinnati So you're telling me you'd rather use the law of cosines here? Why would you use the law of cosines here? Why would you want to use the law of cosines? It's easier? So we could do that. Then it would be, you'd have y squared equals 540 squared plus whatever you have in x squared minus 2 times 540 times x times the cosine of 26. So you're telling me you'd rather type all that in than do a proportion? Okay, well, knock yourself out. You get the same answer. You're using the x's in your calculator. All right, so who has it typed in? Christopher, you have it typed in? What'd you get? Good. 237.045. Thank you. All right, anybody have any questions on that? We're all good on that? Yes. Okay, so when we draw our picture for number 6, let me tell you what happened to me when I worked it out on here. Is I drew my picture, and I was kind of sloppy with my lengths, like, because mine always look equilateral or isosceles, just because that's the way I draw them. And then that didn't work out so well for me when I got to B, and I had to redraw it because then I couldn't make sense of what I had. So we're going to you want to make sure you're drawing these big enough that you can actually label them. And they don't have to be super accurate. You probably just need to be not so sloppy if you're sloppy at all with them. All right, so here is my starting point of my my north, south, east, west here. And it says that leaving from the same port, so here's the port where the ships are going to leave. Ship A sails 8 miles on a bearing of north 45 degrees west. And one of the reasons mine was a little sloppier is because I had my north-south line drawn, but it didn't draw my east-west line, which you don't always have to. But it kind of helps you hit the 45 a little bit more accurately in the other angles. So 45 degrees of north, 45 degrees west. So it's halfway between that 90, right? So it's going to sail out here. Here's ship A. Right? and what was it? 8 miles. Okay, so ship B starts at the same point, and it's going to go south 70 degrees west. So 70 degrees would be about right here. And it's going 14 miles, so I need to make it longer than the 8. That's 14 miles. And this is ship B. And then it says, how far is ship A from ship B? Okay, so this is my X right here. So this was 45 degrees, and this was 70 degrees. Okay, everybody okay with all that? Okay, so in order for me to be able to do something here, I need the angles inside of my triangle. Am I able to find any angles inside my triangle? Yes, because I have these pieces on the outside. I can get these 2 pieces on the inside, right? So the piece, this blue line and my pink line, what would this angle be? 45. And what would this be? 20. Together, the whole thing is 65 degrees. Okay, everybody okay with that? Because you got that 90 from the north, south, east, west. So now I have 2 sides in the included angle. So that's side angle side. So Emmanuel's going to be very excited. We get to use law of cosines. And so that's going to mean I'm going to have x squared equals 8 squared plus 14 squared minus 2 times 8 times 14 times the cosine of 65. Okay. And this says to the nearest 1/10 of a mile because I forgot to change it. But your rule is it's to the 3 decimal places unless it says otherwise. It says otherwise. So we'll give our answer to the nearest 1/10. That's fine. But you're going to need to store it because you need to store the entire decimal because when you reuse it, you can't use the rounded number, right? And so then I can say Vanessa, you have an answer? Okay, so to the nearest 1/10, what would that be? 12.9. Okay, good. So then 12.9, but make sure you store the whatever it said in there because it said more even than the 12.858 because we're going to need it here in just a second. Okay, everybody okay with that? All right, so now it says if ship A sails to ship B, what bearing should it take? All right, so ship A is going to sail to ship B. So I need to have my north, south, east, west in here to figure out a bearing. So if I'm trying to figure out what bearing it should take, it's going to be south something west. We agree with that? So I'm looking for this angle right here. Well, I can't find that angle directly, right? The angle that I can actually find in my triangle is angle A. You agree with me on that? Like we can find angle A. So once I find angle A, I'm going to have to subtract this part right here so that I can have just that piece. That means I need to know what that is. How do I know what this is? It's 45. Because you see this? This is parallel to this because they are horizontal lines. So if this is 45, this is 45, and so is that. So all 4 of these little angles here are all 45. So after I find the measure of angle A, I can just subtract 45 from it and I have my bearing. Do you understand that from the picture? Okay, so once you've decided those things, because a lot of times y'all can decide those things, you're like, okay, yes, and I get it. And then you get in here and you do math and then you're like, you either think you're done or you don't know what to do with it. So we've just decided that the bearing that we're going to get is the measure of angle A minus 45. Now, nobody says that you have to write that down. However, if you do that, then when you're done, you know what to do with what you have and you don't have to go redecide all of that stuff and then confuse yourself because a lot of times that's what happens. You go back into that and then you're really confused about what's what and you don't know what the heck's going on. But is everybody okay with this? Because it's like a lot of little pieces in there. We can find angle A, right? We can do law of sines or we can do law of cosines. But A goes with that 14, so we could just do the sine of angle A over 14, and that's equal to the sine of 65 over x, which you were supposed to store, whether you stored it in x or not, you were supposed to store it. So, or you could do the law of cosines if you want to. That's fine too. But you cross multiply, divide. Remember that it's going to give you a weird decimal because that's the sine of a. We find the measure of angle A in the end. And you get 0.676, right? So is that our final answer? No, it is not. That's the whole angle A. Our bearing is, we have to say this correctly, it's going to be south, and then once we subtract that, 35.676 degrees what? West. Okay, everybody okay with that? Any questions? If you're not drawing and labeling, you ain't never going to figure out where any of that stuff goes. And if you have little teeny tiny pictures that you can't put any labels on, that's going to be a problem for you too. And sometimes you might draw something and then decide that you have to redraw it. That's what happened to me. But make sure that it just makes sense to you at some point, okay? Any questions at all? If you're getting weird numbers on the calculator or you're having trouble, you need to speak up. I said that like 3 times in third period, and finally somebody raised their hand and said, look, I think I'm typing all this in right, but I hadn't got a single answer that you've gotten. And I went over there and his calculator was in gradients because some little jerk that had his calculator before probably changed it and they thought they were funny. And so we had trouble getting it out of gradients. But the little tiny thing that says whether or not you're in degrees is so small you probably can't even tell it says degrees. So just be be honest if you're struggling. I can't help you if I don't know. Because he was typing it in right and he thought he was confused. Okay. All right, so go ahead and glue or tape that in.